Hey there, fifth graders. Today we're going to go ahead and take a look at dividing whole numbers by fractions other than just unit fractions. So we've already taken a look at unit fractions and we saw some nice patterns emerge. Dividing by non-unit fractions or fractions that don't have just a numerator of 1 are a little trickier when you're trying to model it out, but it turns out there'll be a nice shortcut for us by the end of this. So when we're dividing by a fraction, because remember we're going to do whole numbers by fractions, we're trying to figure out how many times that fractional divisor fits into the dividend. So when we're dividing by a fraction, we want to know how many times the divisor fits into the dividend. Okay, so again, we're going to try and figure out how many times 3/4 fits into 3 whole things. So that's precisely what we're trying to figure out. How many times 3/4 fits into 3 whole things. Let's draw a model and figure that out. So we're going to go ahead and create quarters. So I have 3 whole things, as you can see here, and we are going to see how many sets of 3/4 make up these 3 whole things. So I've created a bunch of quarters. And now what I'm going to do is I'm going to circle groups of 3/4. We're going to see how many of them make up the 3 whole things. I'm just getting myself some colored pens ready here. So here's going to be my first set of 3/4. That's 3 of those quarters. Now I'm going to grab another set of 3/4. I'm going to use this quarter and then 2 more over here. So that's 3 total quarters, even though I'm skipping over to that next whole thing. That's okay. I'm going to grab my next set of 3/4. So I've got 2 here and 1 more over here. That's a total of 3/4. And then my last one, here I have a set of 3/4. So it turns out that there are 4 full sets, 1, 2, 3, 4 sets of 3/4. So it fits in 4 times, so 3 divided by 3/4 is indeed 4. So hopefully that's a very nice visual for you to understand that 3/4 fits into 3 4 whole times. Let's do another example. 4 divided by 2/5. We want to know how many times 2/5 fits into 4. So we want to know how many times 2/5 fits into 4 whole things. So here are my 4 whole things. I'm going to go ahead and break these up into fifths. The way I like to do it is I put my finger in the middle and I'll draw 2 lines to either side of my fingernail. And then I'll cut those in half, and that usually creates 5 nice equal pieces. So I put my finger in the middle, I draw 2 lines to either side, finger in the middle, 2 lines to either side, and then you cut those in half, finger in the middle, 2 lines to either side, oops, and then cut those in half. Sorry, that's a little sloppy at the end there. So this time we're going to be taking groups of 2/5. So here's 1/5, another 5th, that's my 2/5. So there's definitely 1 set of 2/5 that fits into 4 whole things. Here's another set of 2/5. Here's another set, 1, and jump over to the next one, 2/5. Here's another set of 2/5. We're going to keep repeating this pattern here. Here's another. Here's another. Here's another. Here's another. Oops. Sorry, I'm changing out my colors here. Here's another. And here's my last set. Now let's count up how many of these sets of 2/5 fit into 4 whole things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. So 2/5 fit into 4 10 times. Therefore, 4 divided by 2/5 is indeed 10. As you can see, that was relatively time consuming. There is a quicker way for us to do this. And I know a lot of you boys and girls are good at finding shortcuts, and this one might not be that straightforward. So recently we learned about a thing called the reciprocal, and the reciprocal is going to be the key to this shortcut. So it turns out that we can turn any division problem in the whole wide world, even whole numbers, We can turn division problems into multiplication problems. But if we change it into multiplication, if we change our operation from division to multiplication, we're going to have to change something else about the problem. Because, for example, if I did, let's say, 10 divided by 2, that'll never be the same thing. That will not be equal to 10 times 2. You can't keep the same numbers and say that when you divide them, it's going to be the same thing as multiplying them. That will never be the case. So the key to making them equal is you need to change another component of the problem. And so the other component that this turns out to be is that it's equal to 10 times the reciprocal of the second number. And that's going to be our shortcut here, is that dividing by a fraction, even a whole number, it's the same thing as multiplying by the reciprocal. So our little saying for ourselves to remember this is going to be keep, change, flip. And you might be like, what in the world does that mean? KCF is going to represent keep, change, flip. It's not KFC. I like to think about it as Kentucky chicken that's fried to perfection. So that's kind of your way you can remember it. And let's talk about what it means. Keep. The keep is we are keeping the dividends the same. We are going to change the operation from division to multiplication. And we are going to flip the divisor to its reciprocal. So here's how this is going to work. We're going to take the two examples we did on the front side. So we already know this answer is going to be 4 and this one's going to be 10 because we drew out the models. And let's see how this keep, change, flip works. And let's see if it even does work, because some of you might be a little bit skeptical, which I don't blame you. So KCF, we're going to go ahead because I'm dividing by a fraction. We're going to keep, change, flip. So I want you to create these columns so that we can keep our work nice, neat, and organized. So this is going to be the same thing as 3. So I'm keeping that 3 the same, times, because I'm changing the operation from division to multiplication, and I'm going to flip this second fraction, and I'm going to multiply by the reciprocal, which would be 4/3. Now I have a multiplication problem, and as we learned last unit, we need to clear the skies, and we need to put the 3 over 1, and now we multiply straight across, and we get 12/3. Well, 12/3 is indeed, 3 goes into 12 4 whole times. It is indeed equal to 4, like we had modeled on the front of our notes. Let's do another example. We know this needs to equal 10. Let's see if multiplying by the reciprocal, actually works. KCF. I like to draw a column so I can stay nice, neat, and organized. So I keep this the same. I'm going to go ahead and throw it over 1 right away, though. I'm going to change division to multiplication, and I'm going to flip that second fraction. You got to make sure you flip it. We could actually go ahead and simplify before we multiply. 1 and 2, and this gives us 10 right off the bat. You could have multiplied. You would have gotten. You could have multiplied first. You would have gotten 20 over 2, which is 10 as well. And we already modeled this answer on the front. So hopefully this helps you to feel better that this does indeed work, and it always will work. So let's take a look at the next one. So we're going to KCF. We're going to keep, change, flip. So this is going to be 8 times 4/3. Do not forget to flip. Put the 8 over 1, multiply straight across. We get 32/3. That's an improper fraction. You know how to deal with that. We turn it into a mixed number. 3 goes into 32, 10 whole times with 2 left over. And your answer is 10 2/3. We're going to keep, change, flip. And this is going to be 6 times 3/2. Put that over 1. We can cross simplify to make life a little bit easier. 2 goes into 6 3 times. Multiply straight across and we get 9. A couple more. Keep, change, flip. We're going to multiply by the reciprocal. So this is 9 times 4/3. Put the 9 over 1. Can go ahead and simplify before we multiply, and we get 12. And the last one, keep, change, flip. This is going to be 2 times 7/2. Can simplify before I multiply, and I get 7. So if you are a fan of multiplying fractions, you should be pretty happy right now, because it turns out that you can turn your division problems into multiplication problems, clear your skies, and multiply straight across.